morning. So I want to quickly talk with you about Kubernetes machine API and how you easily can manage nodes in a Kubernetes cluster. So I'm Sebastian Scheele, co-founder from Loodse, my Twitter hashtag, and we are a Hamburg-based company, have our own product to manage Kubernetes cluster, Kubernetes, and yeah, member of CNCF and also Google Cloud partner, and really focusing on container and cloud-native technologies. And the problem we had in the past is like there are so many different solutions how you can deploy nodes depending on your cloud provider. You can use GKE, AWS, now with EKS, or Terraform, Puppet, Chef, Ansible, even Bash scripts or calling some APIs, but it's every time feels not natively integrated into Kubernetes. So yeah, to scale a cluster, for example, the developers every time needs an ops person because most of the time developers don't have so much knowledge about Terraform or they're not so deep into it. There's not a generic approach, so it really depends, like probably in your own data center, you have a different solution than you're using on the Google Cloud platform than you're using on AWS. And each implementation also needs specific knowledge. So it's also hard to build a generic autoscaler because currently the node autoscaler is integrated with the Google or AWS instance groups, and there's no generalized concept around. Yeah, and if you want to migrate from one platform to another platform, it's mostly a huge effort to rebuild things and to transform your setup to a new platform. So in the past, there were some similar ideas building the coming up like Kubicorn from Chris Nova. We came up with the idea of KubeNode to generalize this. There's Archon from some guys from China. And so Google came up with an idea, and everyone had the idea, okay, somehow managing Kubernetes should be much more natively integrated into Kubernetes. And there's now a working group called Cluster API, where it's focusing on two things. One is, where I will talk about is, it's like how you can spinning up machines with a machine API, and the other is in general a generalized API how you can spin up Kubernetes clusters, so that at the end it doesn't matter which provider you are using, hopefully. So it doesn't matter if you are talking to Google, to Amazon, to your private setup. You can use the similar tooling and can do, for example, cluster API create cluster, and then your cluster is created, or cluster API create upgrade cluster, and then your cluster is upgraded, and you don't need to know about the details how everything is deployed, or you don't need every time know, okay, which tooling they are using and what is the specific command line interface for it. And of course, one heavy part of this is like the cluster API must spin up nodes for the master and nodes for the worker. So, and for this, there is this machine API, and about this I want to talk. So the idea really is it should be natively integrated so that dev can scale the cluster. So you can do kubectl create machine and a new machine is created, and you don't need like Terraform, Ansible, whatever to spin up a machine. It's really also like the idea pets versus cattle for nodes, so that you easily can throw away your nodes and you can easily create a new one instead of in place upgrading them. And when you have this in place, you can implement more easily a generic autoscaler because Kubernetes itself knows mostly best when it's the best time to autoscale because it has all the informations, and then you easily can only like create new machines, and this machine is then calling the API from Google, AWS, Azure, VMware, whatever. And from the user perspective, your setup looks very similar, and you don't need to know like provider-specific details about the implementation. So from a developer perspective, when this is implemented, I can do everywhere kubectl create machine, and I get a new machine attached to my cluster. And it could be on Google, it could be on Amazon, it could be also on VMware or OpenStack. So as a developer, you don't care. You can build tooling around this and can easily manage this natively. So what we want to do, on the one side, extending Kubernetes, it's not built inside the core of Kubernetes, it's a separate repository. At the end, I will show the link to the repository. The first thing is we created a custom resource called machine, where you can declarative specify how the node should look like, and that you can create this. And if you create this machine, Kubernetes will call the API of the specific provider, spins up a node, and then later when the node is coming up, you get the node object back, and the both will be linked together so that internally the system knows, okay, this machine belongs to this specific node. So there is a node machine controller who's every time looking if there is a new machine object created inside of Kubernetes, and when this is created, it calls the API of the cloud provider or of the provider and spins up the machines, ensure that the machine can join the cluster, or even spin up the master of the Kubernetes cluster, spin up like a master with API server, etcd, and all things belong, and then you can join nodes, and the kubelet is configured that it can join an existing cluster. Optional, there should be something like a machine class, somehow similar like you know it already from storage class, so where you can specify generic information about your cloud provider. For example, your cloud provider credentials, specific machine types, when you only want to allow your developers, you want to use this specific machine A, type A, and machine type B, but not C and D, you can the ops team can specify this, and then the developers can only reuse the machine class, so all information belongs, and also some provision details could be included there. And then it really starts like similar as we know it from pods and replica sets and deployments for container. So that the idea is really like machine is your pod in that case, and then on top, we want to build something like a machine set. So a group of similar nodes, which can later be integrated with an autoscaler. So you have like a replication number, you have like the information to a machine class. You could have like also different implementation of the machine controller, and yeah, then you create a machine set and say, okay, I need 4 machines. And then the machine set controller will create 4 times the object of machines, and later, based on this information, the machine controller will create the specific, or will call the specific APIs of the cloud provider. And then on top, there will be a machine deployment. So a machine deployment is really to ensure that you can easily upgrade your cluster, so that you can upgrade your worker nodes, upgrade your master, so that you easily can say, okay, I want to upgrade from 1.9 to 1.10, and then similar like a deployment for containers, you change your information in your machine deployment, and then a new machine set is created. The new machine set is scaled up, and the old machine set is scaled down, and this is like how you can switch to a new version. And yeah, with this you can also easily have different types of machines. So imagine you want to run, for example, in your cluster machines with like high memory, and then you also want to run machines with GPU support. So you could create 2 deployments. One deployment where you specify I want to have machines with high memory, and one deployment with high GPU, or no, with GPU support. So yeah, I want to give you a quick demo how this looks like. So as I said, we built Kubernetes. We already have this implemented. So I have currently running a cluster with 2 machines. And now what I want to do is so we see we have a cluster with 2 machines and 2 nodes. And now I want to spin up a new machine. So, and the machine looks like this. So I have a kind machine, and then I specify my name. So for example, I call it new, and then I have my provider specific configuration. So like on what cloud provider I want to deploy this machine. In this case, I use AWS. What's the availability zone? What's the disk size? So the provider config depends every time on the cloud provider what information must be provided. Similar like in a storage class where it really depends what storage system you are using. But here you can then specify all the informations you need. And this also depends on how the machine controller is implemented. And probably if you say, okay, this looks nice, but for example, features from me are missing, I need some more flex or so, you can easily also build your own machine controller. Currently, all the machine controllers are written in Go, but when you say, okay, I want to integrate this with Ansible, you can write your Python machine controller and call Ansible code out of it. So it's quite flexible. You can also compare like ingress resources. It's only a definition, and then you have a controller who is looking for these resources and then executing some tasks. And for example, here you have also the information about the type. Now I say I need a node, so a worker node. Technically, I could also say I need a master, and then the machine controller should know what to do to deploy a master. Yeah, and then we create this. So we get this information. Now we have a new machine. And let me copy this. And inside the cluster, there's this machine controller running. Probably I'm too late. Yeah, we see it here already. This machine controller every time checks, okay, if there's a new resource is created, and then when it detects that there's a new resource, it starts calling, in our case, for example, AWS, spins up the VM, provides a systemd unit file, and technically then it's mostly do kubeadm join, and then the machine is joining, and then it mostly depends. Let's see how fast it is, if we already have the node. It really depends only like how fast the cloud provider is, that the node is coming up and that you get a node in the cluster. And but what you also can do is like, can say I want to delete a machine. So now similar, it takes now some time until it's deleted. So let's see the status. Here we see should work. We see it at least in the log. We see that the deletion is triggered, and now it's waiting. So as soon as it's completely deleted, the resources will also go away inside of Kubernetes. So, and then hopefully, now we see already the instance is already deleted, and hopefully in the next 1 or 2 minutes, the new instance will come up. So really the developer can now scale their cluster or manage their cluster. Or I can easily decide if developers can do this or not. I can restrict this with airbag rules to say, okay, is he allowed to do? But I don't need to know a complete different tooling for managing my cluster. And yeah, that's mainly what I want to show. So machine API is only a small part of it, or a bigger part of cluster API, and the rest is then really a umbrella how we easily can manage the whole life cycle of a Kubernetes cluster. Yeah, these are the two repositories. There's an old one, Kubernetes /kube deploy. And this is currently in migration. I think it's now finished. And there's a new repository, Kubernetes 6/cluster API, where you find all the code and all the information and how it's going on. Let me check the time. Probably we have time for one question. Afterwards, I'm also here if you have a further question. Does anyone have a question? Okay, no questions. Perfect. If you have questions, I'm here around. So thanks for your time, and I hope you enjoyed it.